Good morning, guys. Hey, give me a sorry, I'm running a little late today. Give me a quick thumbs up if you can hear and see me. All right, Tara can hear me. Adam's good. All right. Um, hey, hope you guys are doing good. Welcome to class today on this Monday. Man, I'm always asking myself what day is it all the time. So welcome to Monday class. I hope you guys are doing extremely well. Wanted to I sent you a message last night. All grades are in, so everyone that turned in something, it is in the grade book now. So whatever it is that whatever it is that you turned in, it's in the grade book. It's graded, and your grade should reflect whatever it is. And your grade should reflect whatever the fourth quarter grade is. So what your grade is right now is what it is with everything updated. Just wanted to let you know that. Without wasting too much time, let's jump right into this lesson 5.1 homework. Any questions on 5.1 homework? Type them into the chat box now. Taylor said 32. Okay. So Jamie said 31. All right. So looking at number 31 real quick. So looking at 31. So 2x raised to the... All right, so everybody's saying 31 and 32. Cool. Let me catch my Zoom back, my time back up. Okay, cool. So 31 and 32. So looking at number 31, 2x raised to the 1/4 power. Okay, yeah, this one may be a little bit tricky, okay? Because notice it's not the whole thing to the 1/4 power. It's just the x raised to the 1/4 power. So this would look something like this right here once we started to solve it. It would look like, oops, sorry. It would look like this, 2, and then the radical would be 4. The index would be 4 of x equals 4. Now, if it looked like this, 2x to the 1/4, that's when we would know it would be the index is 4 of 2x, right? But with the x just being to the 1/4, we write it as the 4th root of x. Then from here, we divide both sides by 2 because our goal is to isolate x. So divide both sides by 2. That cancels, and then I get the 4th root of x is equal to 4 divided by 2 is 2. Okay? And then here, the inverse operation of taking something to the 4th root is raising both sides to the 4th. So let's raise both sides to the 4th. Cancels, cancels, and I'm left with x is equal to 2 to the 4th would be 2 times 2 times 2 times 2, which is 16. Give me a thumbs up if that makes sense for number 31. All right, cool, yeah. That's the difference is just the parentheses, guys. Difference is just the parentheses there. Same thing over here. You're going to add 1 first before we do anything crazy. And that takes us to 3x to the 3/2 power equals 192. Then from there, again, it's the same thing as this over here, guys. It'll look like this, okay? Same thing as over here, but it's going to look like this. 3 and then times, so we'll say times the square root of x cubed here. Yeah, of x cubed equals 192. I was thinking whether I should put the 3 on the inside with the x or on the outside. I think it's easier on the outside once we divide out. So this is being multiplied, so I can still divide by 3 on both sides. Oh. My calculator is flat dead. So 192 divided by 3. 3 will go into 19. 6 times giving me 18. I'm left with 1. Drop the 2, so 4. So 64. So the square root of x cubed is equal to 64. Once I divide both sides by 3, then from there I just need to cube root both sides. That's the inverse of cubing. So the cube root and the cube cancel. And then I'm left with the square root of x is equal to the cube root of 64, which would be 4. 4 times 4 times 4 is 64. So what times itself 3 times is 64. And then from there, we just got to square both sides. The inverse of square root is squaring. What I do one side, do the other. Cancels, cancels. X is then equal to 16. All right. Does that make sense to you guys that had that question? Give me a thumbs up if that makes sense. All right, cool. Very good. Makes sense. Are there any other questions? All right, no other questions? You had your answer sheet to that. You could easily look over that. Okay. Hey, now, while I'm here, before we get going with 5.2 notes, hey, something, when you guys turn something in, don't turn the notes in. Put the notes in your homework. Or, excuse me, put the notes in your binder, okay? And when I say, hey, turn something in like at the school or send it to me, I just want the homework, no notes. You keep the notes for you. Just rip it off and then put it in your binder so you're keeping the track in your binder, okay? That's no problem this time. I have all those. Like I said, they're graded. I'll give those to you when we see each other again, which is hopefully soon. I don't know if we'll have to do another drop-off or pick-up or what. No telling. I'm sure the governor will have more news today in terms of school and stuff, so we'll kind of see about that in the time being. I'm going to try something else. I'm going to try a mic. I want to see if that... tell me if this mic helps you hear me, or if it makes it worse, or it makes it the same. I want to try a new mic. So you tell me if it like, hey, that made things worse, Mr. Ipoc, or tell me about it. Can you hear me? I'm assuming you can hear me a little bit. Does that sound any better? Or is it about the same? Okay, Tara said yes. So which question, Tara? Does it sound the same or does it sound better? Okay, about the same. Okay, cool. All right, I'll take it off then. I was wondering. Mac has pretty good sound, so I figured it did, but I didn't know, so I figured I'd try it out. So it's all over the place. Some people say it's better, some people say it's worse, some people say it's the same. So we'll just keep it as normal within that. So, all right, jumping into lesson 5.2 notes, and this is properties of radicals. Now, keep in mind, radicals are just those signs there. It can be more than just a square root. You know, it can be a cube root, as we've discussed. It can be a fourth root. So these are properties of those roots, and this is lesson 5.2 notes. So 5.2 notes, we're just talking about different properties. Before we go too far into those properties, let me make sure. Yeah, we went over those properties kind of before. Okay, so there's basically going to be two properties that we're going to deal with radicals. Okay, now let's talk about addition and subtraction real quick. So addition of radicals would look like this: radical A plus radical B. That would just simply be radical A plus radical B. There is nothing you can do with those. Just an example, like if you had radical 4 plus radical, I don't know, let's say 17, you can simplify this radical 4 to a 2, but it's still just going to simply be radical 4 plus radical 17 at the end. Or we could say 2 plus radical 17. And that's going to give us some number, okay? And addition and subtraction are going to be the same. So same way with subtraction, if you had radical A minus radical B, there's nothing you can do with that. So it's just simply whatever radical A is minus radical B. For instance, if I have radical 3 minus radical 2, neither one of those could be simplified. It's not radical 1 because radical 1 is 1. And radical 3 minus radical 2 is not radical 1. It's just simply radical 3 minus radical 2, which is some decimal. Okay? So nothing really you can do with those. But what you can do something with is the product or multiplication of radicals. Okay? And we would just simply call that the product property of radicals. The product, let me get myself out of the way a lot. The product property of radicals. Okay? So, looking at that product property of radicals, it simply says this right here, that the nth radical of A times the nth radical of B, as long as the index is the same, you can simply just multiply doing this, A times B. Okay? So radical A times radical B is just simply multiplying both of the insides together. And then same way with the quotient property. it simply states this. Radical A divided by radical B is equal to radical A divided by B. Okay, so let's jump, and that's your basic rules you need to know. When you have two radicals, like I said, over here with addition and subtraction, can't do anything with them. Can't simplify them, can't make them do anything. But with over here, there is something you can do. When you have two radicals that are being multiplied, you just multiply their insides. Okay? You multiply their insides. Quotient rule, when you're dividing, you just divide the insides or simplify, whichever one would possibly work. And we'll see plenty of examples today. Okay? Plenty of examples. Okay? So here we go. Looking at number 1. It says simplify. Radical 6 times radical 6. Well, again, this is the property, the product property. So when you have a radical times a radical, you are simply just going to say radical 6 times 6. Again, radical A times radical B is just radical A times B. You just, whatever's on the inside, you put it together. And that's going to be equal to radical 36. Which is equal to 6. So radical 6 times radical 6 is equal to radical 6. Okay, now I'm sure some of you are saying, well, hold on just a second. That looks kind of awful familiar. That looks kind of intriguing right there, Mr. iPop. That whole radical 6 times radical 6 simply gave us 6. So there is a shortcut here. Anytime you are multiplying, the same radicand, which is what is on the inside of the radical. Anytime you're multiplying the same radicand, it will be that number. So, radical 9 times radical 9 is 9. Radical 13 times radical 13 will just simply be 13. So anytime you have the same thing multiplied by the same radical, it's just whatever's underneath the radical. Anytime you're multiplying the same radicand, same thing on the inside, it will be that number or whatever that expression may be. All right, let's jump over here to number 2. Radical 2 times radical 6. What do you do with those? You just multiply them. That goes to radical 2 times 6. All right. Now, 2 times 6 is, since they're not the same, it's obviously not going to be the same number. 2 times 6 is equal to radical 12. Now, here's the question. It says to simplify. Can radical 12 be simplified? Yes or no? Type that in the chat box. Someone type that into the chat box. Yes or no? Radical 12 can be simplified. I got 3 straight no's. Tara says yes. Tara said no, then she said yes. The answer to that is yes. You can. You can simplify radical 12. So this kind of goes back to, remember when we were using quadratic formula and you had like a square root and you said, hey, how can I simplify this? So you ask yourself, what perfect square root goes into 12? Well, remember we'd bring it up here and we'd say, well, 1, 4, 9, 16, 25, 36, 49. And we'd say, which one of these will go into radical 12? I hope you guys remember that. Okay? This was a struggle. This was a struggle train right here with us. So it's a very easy concept. Okay? Give me a thumbs up or something in the chat box if you kind of remember doing this. And then from here we would say like, oh, that's radical 4 will. And then what times radical 4 will give me radical 12? Radical 3. So Tara remembers it. Thank you, Tara, for responding. Adam remembers it. Good. McKinney remembers it. Okay. So, and what you didn't even know at the time is that this right here, this rule, how we would go from radical 12 to radical 4, radical 3, that is, guys, that's literally what we're doing right now. Okay? Look at this. When you have radical 4 times radical 3, you just go there. We're just going backwards. We're going the other way now. Okay? Kind of, I guess. So here, that's 2 radical 3. So that is equal to 2 radical 3, and that would be our answer. Okay, I hope that's making a little bit of sense to you. Okay, continue right along. Look at number 3. Radical 2 times radical 3. Well, that just becomes radical 2 times 3. Well, 2 times 3 is radical 6. I ask myself, will any perfect square root go into 6? Someone answer that in the chat box. Yes, no, maybe? Tara says no. Maria says no. Very good. Yeah. So no perfect square. We're going to that. So that would be my final answer. Yeah, very good, Adam. Only 1. 1 is the only thing. And really, I should probably take 1 off that because 1 doesn't matter. All right. What's the answer to number 4? I should see a slew of responses right now. What's the answer to number 4? Yeah, there you go, guys. Good, good, good. Anytime you have a radical times the same radical, it's just whatever's underneath the radical. 3. Okay? Very good, guys. All right, looking at number 5. So number 5, okay, we have radical 3m times radical 2m squared. One second, need to get my charger for my Mac. Okay, sorry about that. So looking at this, okay, here's where we need to go. Radical 3m times 2m squared. Okay, now this is where it gets just a little bit tricky, but I think you guys will kind of see this pretty quick. But it does get a little tricky here. So this, when I multiply 3m times 2m squared, you guys would know that that would give me 6m cubed. Okay, now that appears to be our answer, but there's an issue there. The issue is this, is that there's a squared with a radical. Okay, so watch this. 6m cubed can be rewritten. Okay, so understand this. This right here is the product of something. All right? Now, this first one, I'm going to break it down piece by piece by piece. Okay? So, here's what it would actually look like. It could look like this. The square root of 6 times the square root of m cubed. That's just me separating it, guys. Don't freak out on me. But that's just me separating it. And then, notice here, 6 times m cubed. But now this is the unique part right here, is this over here. This could be broken down, so let's just bring that radical 6 down. This could be broken down to where it looks like this. Radical m squared times radical m. Sorry about that, guys. I'm trying to get my dog quiet. He's barking. I'm sure you all hear him in the background. So let me just reiterate what I just said. So again, think about this from what I just taught you. Radical 6m cubed can be broken down into radical 6 times m cubed. That's us going backwards. Okay? Think about if we went from here to here. 6 and 2 radicals, just multiply the insides, that would take us there. Well, I just dropped the radical 6, and then this radical m cubed split down into m squared and m. Radical m squared times radical m. Then I can cancel the square and the square root, leaving me just the m. Hey, give me 1 second. Okay, so the square root and the square cancel. All right, so that leaves just an m out here. Okay, and then notice with this, radical 6 times radical m would just simply be radical 6m. And that would be my answer. All right. So there we have a couple more of those guys. So no reason to worry or anything. We're gonna get enough practice. So let's jump over here to number 6. Radical 2n times radical 3n squared. So that would take us to 6n cubed. So very similar to number 5. Let's just kind of work through that process again. So I got 6n cubed by multiplying 2n and 3n squared. So I'm going to take this over here and I'm going to say 6n cubed. Now I can break that down like this. Radical 6 times radical n cubed. So radical 6 times, and then this can be broken down into radical n squared times radical n. And guys, the reason we can do this is that this rule up here, it goes this way and this way. So equation sign go both ways. So that's what allows us to go from n cubed to n squared times n. Now watch this. My square and square root cancel, leaving me n. And really what I'd have is radical 6 times radical n. But we know our rule now is that we can put those together. So it's n radical 6n. All right, let's look at number 7. So number 7 says this. Radical 3k squared times radical 2k. So if I multiply the insides together, I get 6k cubed. Now you should be getting in the habit to see this, okay? You should be getting the habit to kind of see this a little bit better now. What we need to get out of that k cubed is a k squared. So really, guys, I could do this. Radical 6k times radical k squared. And again, that's the same thing as what we're doing up there. It's just we're not doing as many steps now. So he said 6k goes here, and the other k squared goes in its own. That allows us to cancel that, giving me, there's nothing left here besides a k. K times radical 6k. Give me a thumbs up if you're seeing this. Okay, give me a thumbs up. Hey, I'm seeing this. It's making a little bit of sense. I want to make sure you're still with me. All right, Adam's good. Chris is good. Tara's good. Andy's good. Kenny's good. Jesse's good. Catherine's good. Okay, cool. Glad you guys are with me. Let's jump to the last one. Radical 2n squared times radical 4n. My dog, he's on it today. He don't know what to do when we're all here. Come here. Let's go. Come here, boys. Come here, boys. I'll show him off to you real quick. Up. Rocket, come here. Come here, boys. Up. I don't know if have I showed you guys Rocket before? Come here, boys. Come on, boys. Come on, up. Come on, up. Get up here. Those your boys. Get up here. Say hey. Look at the camera. Oh. Come here. Come here. Come on. Get up here. All right. Trying to see if he can get up here, but he won't. I actually do this at our kitchen table, and he's not supposed to be in the kitchen, so he's a little bit nervous about it being in the kitchen right now. Let me bring him back. Up, back. Come on, back. The little bit of attention should kind of help him ease up now. Okay, so continue right along. Going to this right here. The next one, that would be radical 8n cubed. And then, like we did a while ago, I want to take an n squared out of there. So what would I have to multiply this by to get that? Well, I would just need 8n. See, now look, if I went back to that, 8n times n squared would be 8n cubed. So that shows me that I've done that right. Then I cancel that, and I'm left with n radical 8n. Oh, whoa. Actually, no, I'm not. Stop. Okay, so let's actually erase that. I'm sorry if you're writing with a pen, Adam Oral. Quit writing with a daggum pen, kid. So going back to this, there is actually one thing I'm missing, okay? So actually, let's break this one down to radical 8, to radical n squared, and radical n. Now again, if I multiply all these together, I'm going to get 8n cubed. But where I made my mistake was this, is that 8 can be simplified, okay? 8 can be simplified because there is a number up here that will go into it, and that number is 4. So the square root of 8, so you got to be careful and watch for it. Now notice with the 5, 6, and 7, they all had 6, and 6 can't be simplified. So be careful. Don't let that catch you like it almost caught me. So that can be broken down into radical 4, radical 2. Because radical 4 times radical 2 is radical 8. So then we say 2 radical 2 times radical n squared times radical n. Then the square root and the square cancel. And that n is by itself, so I can push that out front and say 2n radical, and then that 2 times that n would just simply be 2n. And that would be my final answer. And I could have got there from there just by bringing the radical out by itself, but I thought it'd be better to show you like this. Okay? So same process, but if that number there can be simplified based on a radical, then you have to pull it out and simplify. So simplifying radicals is just breaking them all apart, seeing what you can simplify with each one, and then putting them all back together at the end. All right, give me a thumbs up if you're good with 1 through 8. That's just multiplying radicals. All right, looking pretty good. Jumping down here to number 9, it says simplify these. Now notice this is distributive property, okay? So distributive property, the same kind of rules apply. So let's jump into it. So number 9, radical 2 times 2 plus radical 2. Distribute, distribute. All right. So radical 2 times 2. So radical 2 times 2. Now look, that doesn't have a radical on it. So the way you write that would just be like this. 2 radical 2. Put the 2 in front. Because if not, then it could look like it's under the radical. So radical 2 times 2 is just 2 radical 2. And then plus 2, or excuse me, radical 2 times radical 2. That should just be what? Radical 2 times radical 2 is just, if it's the same, it's just whatever's under it. So it should just be 2. Now, a lot of people will want to say this right here. Oh, then that's 4 radical 2. But that is not right, guys. This right here is my final answer. You cannot add that 2 and that 2. Treat radicals, you're going to hear me say this a lot, treat radicals like variables. Treat radicals like variables. If they're not alike, you cannot add them. That's like saying this, 2x plus 2, and making that 4x. That does not equal, okay? So you just have to leave it. If it was just 2x plus 2, you just have to leave it there. Same thing here. Treat that like a variable. If it's not the same as that, then you can't add. And I think we get into maybe 1 or 2 that you may be able to add. I'm not 100% sure. So if you were able to add, it'd look like this. 2 radical 2 plus 2 radical 2. Then that's like the same variable. That's like saying 2x plus 2x. So then that would be 4 radical 2. That's what would be 4 radical 2. Okay? When you have the same radical there and you're adding, that is when you can add those 2. Just like that would just simply be 4x there. Okay? All right, looking at number 10. Same thing here. I just need to do distributive property. Distribute, distribute. Now, what is radical 6 times radical 2? Radical 6 times radical 2 is radical 12, because 6 times 2 is 12. And then plus radical 6 times radical 6 is just simply 6. And if you're saying, man, I'm not getting that. Well, think about if you multiplied 6 times 6. That'd be 36. Radical 36 is 6. So anytime you multiply the same radical, it's just whatever's under the radical. Now, this would appear to be the final answer, but always ask yourself, can this be simplified? And the answer to that question is yes, it can. 4 will go into that. Radical 4 times radical 3 will give you radical 12. So then that would be 2 radical 3 plus 6. The 2 comes from the radical 4. The radical 3 just simply drops down. And that right there is my final answer. All right, let's jump to the back side. Okay, so now what are we going to do here with 11 through 14? Someone tell me what we're going to do with 11 through 14. What is that acronym? Very good, Tara. FOIL. We will use FOIL here. When you have a binomial times a binomial, we will use FOIL. First, outer. first, outer, inner, last. Very good, Molly. FOIL. So we FOIL this. So here we go. We got first. Pay attention here. Radical 3 times negative radical 3. Anytime you have the same radical multiplying by itself, it's just whatever's under it. So that should be negative 3. The negative comes from that negative right there, guys. Okay? Now, that's first. Now let's go outside. Outside, radical 3 times negative 2. Now, anytime you're multiplying a radical times a constant, just put the constant out front, guys, and it's going to be negative. So that should just be negative 2 radical 3. Again, we put the 2 in front of the radical 3 because we don't want a 2 to be right here, and it'll look totally weird. So this is the standard kind of format of writing it. So that's outside. Now we go inside. Inside, 1 times negative radical 3. Well, anything times 1 is itself, so that will just be minus radical 3. And then 1 times negative 2, the last. First, outer, inner, last. 1 times negative 2 would just be minus 2. All right, now we just need to combine like terms. So I have negative 3 and negative 2. Negative 3 minus 2 is negative 5. And now notice here, we know that there's a 1 there, guys. We know that there's a 1 right there. So remember I said treat these like variables. Treat these radicals like variables. So it's like both of these being an x right here, okay? So it'd be like negative 2x minus 1x. So negative 2 minus 3 would be negative 3. And then you just attach the radical 3, just like it's a variable. Okay? And that would be my final answer. All right, let's jump over to number 12. Radical 5 plus 4 times radical 5 minus 4. So here's what this is going to come out to be. So I'm going to say first would be radical 5 times radical 5. Radical 5 times radical 5, when it's the same thing, it's whatever's underneath. So 5. So that's first. Then I go outside. Radical 5 times negative 4 is just negative 4 radical 5. Go inside. 4 times radical 5 is just simply plus 4 radical 5. And then last is 4 times negative 4, which is negative 16. All right. From there, notice, combine like terms. 5 and negative 16. So 5 minus 16 would be negative 11. Okay. Now, looking at the other two, that negative 4 radical 5 plus 4 radical 5, again, treat these like they're x's. If I had negative 4x plus 4x, that just simply cancels. So negative 11 would be my answer here. Now, one may say, well, why did we get a nice, even, smooth number on this and not on this? And if you look at this right here, you guys know this word. These right here are called complex conjugates. we discussed complex conjugates when we did imaginary numbers. Okay? When we got introduced to imaginary numbers, that's where we learned about complex conjugates. It's the same thing, but the middle sign's the difference. All right? Any questions so far? If you have a question, type it in the chat box. If you're good with this, give me a thumbs up. All right. Seeing no questions, let's continue on. Let's go to this next one. So we got negative 5 times 1 is negative 5. That's first. Outside, negative 5 times negative radical 3. That would be positive because a negative times a negative, we're on the outside one, we're on the O of FOIL. Outside, negative 5 times negative would be a positive 5 radical 3. Go inside, negative 4 radical 3 times 1. Anything times 1 is itself, so that's just minus 4 radical 3. And then go last. Okay? Now, this one's a little bit different, and let me show you why here. Okay? This is what this one looks like. A negative times a negative, we know it's going to be positive. But here's what it looks like. 4 radical 3 times radical 3. All right. Now, I know some of you may want to jump on the bandwagon and say, oh, that's just 3. But notice the 3 has a 4 attached to it. So this could be rewritten like this because that just means multiplication. 4 times radical 3 times radical 3. Now, the cool thing is it doesn't matter which way you multiply. Okay. So you can multiply this first or this first. Now, with addition and subtraction, it does matter, order of operations. But with multiplication here, you can do this first and then that, okay? So radical 3 times radical 3 is 3, and then drop your 4 down, that equals 12. So that's actually plus 12. Then we combine our like terms. Once we combine our like terms, we should see that would break down. Negative 5 and 12 would make 7. And then 5 minus 4 is 1. So that would just be plus radical 3. 1 radical 3, but we know we don't have to put the 1 there. All right, going to the last FOIL one. So we want to go first. 5 times negative 5 is negative 25. Go outside. That would be plus 5 radical 3. Go inside. That would be negative 5 radical 3. And go last. That would simply be plus 3. So negative 25 plus 3 would be negative 22. And then 5 radical 3 minus 5 radical 3 would be nothing. And again, it doesn't necessarily look like a complex conjugate, but one sign is different, so that's the sign that's what matters. So negative 22 would be our answer here. All right. That is it for the FOIL. Now let's jump down here to in the multiplication. Now let's jump down here to the division. All right. Now, I want you to look at number 15 real quick. Someone type in what you think the answer is into the chat box. Type it into the chat box what you think the answer is. It's pretty obvious. It's not a trick question. What do you think the answer is for number 15? All right, Tara says multiply by the bottom number. Anybody else have a shot at that? $225, Chris says. Anybody else? Molly says 3/5. Kenny says 3/5. Okay, so just want to give you a chance to respond. 3/5 is actually the answer here. 3/5 is the answer. Radical 9, the square root of 9 is just 3. Square root of 25 is just simply 5. So 3/5 is the answer. All right. So just wanted to kind of show you that. It's that simple, guys. You can do that every time. But I want to show you the way our rule used it on the front as well. Here's what the rule said, that if you have something like this right here, that it could be broken down into this. Radical 9/25. All right. So just want to show you that right there, is that it can be broken down like this. Now, the thing here is this, is that can one number go into both of those? Okay. And one number can't go into both of those. 3 will go into that, but 3 won't go into 25. 9 will go into itself. Nothing else will go into that. Okay. So if you ever do this right here and you can't simplify, then you just need to go back and just simplify this right here. This one's pretty simple. You can obviously see that it's just 3/5. Just trying to show you that you could put it under here and see if it simplifies, okay? This doesn't, because it simplifies out here, all right? We'll get to, you'll kind of see the understanding behind that once we get to one that will. All right? Jumping to 16. So again, really, I just want you to get in the train of thought that you can do this, 5/9. No one number will go into either one of those. So just come back here and simplify. Well, nothing will go into 5, so that's just radical 5/3. Because the square root of 9 is 3. Okay, looking at 17. Take 17, radical 20/45. Now, there is a number that will go into both of these. Okay, the number 5. Okay, and we're not even asking like what perfect square root will go into it. We're just saying what will one number go into both of these, and the answer is yes, 5 will. So if I divide both those by 5, I get that to be 4 and that to be 9. And then that can be reverted back to this, radical 4, radical 9, which is simply 2/3. Now, the alternative for doing this right here, if you can see that, that's good. I wanted to kind of show you that these two are equal, but you can't really do anything there. Here, once you set it like this, then you could do something that made the problem much easier. But if you didn't have that, you would have to work the problem like this. You would have to say, what perfect square root goes into 20? Well, 4. So you break that down into radical 4, radical 5. And what perfect square root goes into 45? Well, 9. Radical 9 times radical 5 is radical 45. So we'd have that right there. And then notice that this cancels with that. And then that gives me my 2 over 3. So same answer, 2 different ways to do it. Totally up to you which one you do. Sometimes this works. Sometimes it doesn't. Okay? This will work every single time. Okay? Because you're simplifying them. All right? Now go over here to 18. So 2/3 is my answer there. Looking at 18. Now if I take that to look like this, can I say 12 over 25? No one number will go into both of those. So I need to basically look at it the other way. And say, okay, radical 12 and radical 25. Well, radical 25 is 5 over radical 12. Now, up here when we had this, radical 5 and 3, I couldn't do anything with radical 5, so that's your final answer. But radical 12 right here, this right here, can be simplified. So the perfect square root 4, that's where we ask ourselves, what perfect square root will go into that one? And we know that 4 will go into 12. It'll go 3 times, and we put that over 5. 5 came from the radical 25. 12 just moved over here. We couldn't go about it this way, so we're going about it this way. Radical 4 is 2, so 2 radical 3 over 5. All right. Okay, so now we go to the next one. Radical 10 over radical 15. All right? So, this poses something a little bit different. So, I'm fine with this going like this right here. 10 over 15. Okay? 10 over 15. We know that we can divide 5 on both sides and get that to be radical 2/3. 5 will go into 10 twice. It'll go into 15 3 times. And then we know that could take us to radical 2 over radical 3. Now, neither one of these are perfect square roots, and no square root will go into it besides 1. So it would seem that this is the right answer. But there is one stipulation when you're dealing with radicals, okay? And it's called rationalizing denominators. Okay? And what that means is this, and you must always do this when you're working with radicals. Never leave a radical in the denominator. Make sure you're getting this. This is so important. So if I ever say, make sure you rationalize your denominator, I'm saying don't leave a radical in the denominator. So you may be saying, well, okay, this is radical 2, radical 3. Well, how are we going to get this radical out of there? Now, the rules of fraction simply say as long as you do to one thing that you do to what you do to the bottom, you do to the top, you're good. Okay? So, someone type this in the chat box. I want to make sure you're still with me. What could I multiply the denominator by in order to get rid of the radical? And it's not squaring it. It's not doing anything like that, okay? Not squaring it. Don't think about that. That's not how you rationalize the denominator. But what could I multiply? I'm going to put something right here that I can multiply the top and bottom by. And what would I be able to do to get the radical off? What would I multiply by to get that radical off? And if it's going to be a radical, and you can just say radical and then whatever the number is in the chat box. Or you can say rad. Yeah, very good, Adam. Adam said 3, and I'm assuming that Adam means radical 3. If you say radical 3 there, and then what you do at the bottom, you got to do the top. Now think about this. Radical 2 times radical 3, you just multiply what's on the inside. So 2 times 3 is radical 6. And then here, radical 3 times radical 3 is 3. That's how you rationalize the denominator right there, guys. You just multiply by whatever the denominator is in order to get that radical out of there, because radical 3 times radical 3 is 3. And then what I do at the bottom, I got to do the top. Radical 2 times radical 3 is radical 6. Now, some of you may be saying, well, can't we simplify this to 2? No. That's not 6 over 3. That's radical 6 over 3. And radical 6 is an irrational decimal. So it's a decimal, I think, like 2.4 something. Okay, 2.4789, I don't know. So that is not the same as just a regular 6. So right there is my final answer. From there, I need to multiply, or let's go to number 20, sorry. So radical 4 over radical 5. Now radical 4 is obviously 2, and anytime it gives you something like that, you can change it in the beginning, okay? So even with these up here, like, you don't have to do that. You can just go straight to 3 and then see what you can do from there. Okay, so this gives me radical 4, so that's 2, and then radical 5 is just simply radical 5. But the key with this is that you cannot have radicals in the denominator. So you need to rationalize the denominator, which is meaning just never leave it alone. So just multiply by whatever it takes to get the radical out. In this case, it's just simply radical 5. Now we know that produces 5 on the bottom, and on top, 2 times radical 5 is just simply 2 radical 5. When you have a constant and a radical, you just got to leave it like that, guys. Give me thumbs up if that's making sense. Give me thumbs up if that's making sense. Adam's good. Kenny's good. Tara's good. Good. Catherine's good. Andy's good. Jesse's good. Cool. All right. So let's jump down here to 21. So radical 3, radical 2, neither one of them are perfect square roots. Neither one of them can be simplified, so I just need to get radical 2 out of the denominator. So I'll multiply top and bottom by radical 2. And radical 3 times radical 2 is radical 6. And then radical 2 times radical 2 is 2. And that is not, just like up here, that is not 3, because that's radical 6 over 2. Jumping over here, radical 8 and radical 12. Okay? Now, neither one of these are perfect square roots, but will one of these perfect square roots go into it? And the answer to that is yes. Okay? So the square root of 8 can be broken down to this. Radical 4 times radical 2. 4 times 2 is radical 8. Now, it only makes sense to do this. It only makes sense to do this if you have one of these are going to be perfect. Okay? Like, for instance, if you had radical 15 and you said, well, that's radical 3 times radical 5, well, that's true. Okay? But neither one of these do anything, so there's no point in doing that. So you just keep it as radical 15. But here, when you have like radical 8 and something, a perfect square root will go into it, you rewrite it like that. Same thing with 12. 4 will go into that. Radical 4 times radical 3. Now, since we're multiplying here, guys, we know that we could cancel those, actually. We can cancel those right there. And then from there, we could get radical 2 over radical 3. Multiply top and bottom by radical 3 to rationalize the denominator. And you should get radical 6 over 3, just like we did for 19. All right, that completes all the monomials. Now let's come down here to like a binomial, okay? So almost done, guys. Hang with me. Thanks for being patient with me today. Radical 3 over 2 plus radical 2. So that would, guys, be right here. This is where that whole complex conjugate thing comes back in. We did that with imaginary numbers. We're doing it now with simplifying basically quotients with radicals in it, or division problems with radicals in it. All right, so the only way right here, guys, the only thing to multiply by to get that radical 2 out of there would be the complex conjugate, which in this case is 2 minus radical 2. And what I do at the bottom, I have to do to the top. 2 minus radical 2. And that's what we call complex conjugates. You don't have to write that down, just writing it down. Complex conjugates. All right, so then we distribute. That would be radical 3 times 2 is just 2 radical 3. You can't simplify that anyway. It's just that. 2 radical 3. And then minus radical 3 times negative radical 2 would be minus, of course. And then radical 3 times radical 2 is radical 6. You multiply the inside. That's all over. Now we FOIL this. First would be 4. Outside would be negative 2 radical 2. Inside would be plus 2 radical 2. And last would be minus 2. So again, first 2 times 2, 4. Outside 2 times negative radical 2 would just be negative 2 radical 2. Inside 2 times radical 2 would be plus 2 radical 2. And then last, radical 2 times radical 2 is 2. And then notice, guys, negative 2 plus 2 cancels. And I have 2 radical 3 minus 6, bring that from the numerator, over 4 minus 2 is 2. Oh, and sorry, guys, this does have a radical on it. Sorry, not just minus 6, but minus radical 6. So I just brought the numerator down, canceled that. 4 minus 2 is 2. Looking at 24, moving right along. 24, and this is my final answer. Nothing I can do there, guys. Nothing else I can do. I rationalized the denominator. I got the denominator. I got the radicals out of the denominator. And this would be my answer, simplified. All right, so moving right along, jumping over here, I need to multiply this side by 2 minus radical 5 and 2 minus radical 5. Now, let's take care of the numerator first. So distribute, and that will take us to 5 times 2 is 10 minus 5 times 2 is 10, and then minus 5 times radical 5 would be 5 radical 5. Okay, now here's what I wanted to bring you back up with this, guys. Anytime you're multiplying complex conjugates, there's a shortcut, and here's the shortcut. It's a squared minus b squared. So you don't have to FOIL if it's complex conjugate. You just say whatever a is and minus whatever b is, or a squared minus b squared. Now, before we do this one, let's come back over to this one. We know the answer is here is 2. So if I'm looking at 2 plus radical 2, okay, this is a, this is b. And I say a squared minus b squared. So that would be 2 squared minus radical 2 squared. Well, 2 squared is 4. 2 squared is 4. And and 4 minus radical 2 squared is radical 2 times radical 2, which we just found out to be 2. So 4 minus 2 is 2. So that shows that. That shows that this works. This little formula right here, to me, it's much easier than FOILing. Okay? So that's a little shortcut when you're using complex conjugates, a squared minus b squared. So in this case, we just need to say, well, 2 squared minus radical 5 squared. That would be 4 minus radical 5 times radical 5 is just 5. That would be negative 1. So, when you divide something by negative 1, you just change its sign. So it should look like this. Negative 10 plus 5 radical 5. All right, continue right along, guys. Looking at number 25. So 5 plus radical 5 over 5 minus radical 3. Same thing here, complex conjugates. So I'm literally going to say 5 plus radical 3 and 5 plus radical 3. Now, I can use the shortcut on the bottom because they're complex conjugates, but the top is not complex conjugates. Okay, the bottom, they're complex conjugate. The middle sign is different. The top is not. So let's FOIL the top. Okay, let's FOIL the top. So that'd be first. First would be 25. I'm going to write down here. Outside would be plus 5 radical 3. Inside would be plus 5 radical 5. And last would be plus radical 15. Again, that's just FOILing the numerator. I'll go through that again just in case I went too fast. 5 times 5 is 25. Outside, 5 times radical 3 is 5 radical 3. Inside, radical 5 times 5 is 5 radical 5. And last, radical 5 times radical 3, you multiply the insides, plus radical 15. And all that is over here. Let's do a squared. You can do the other one. You can FOIL that if you want. I'm just going to do the shortcut a squared minus b squared. So that's 5 squared minus radical 3 squared. So that's 25. 5 squared is 25. And then minus just 3 there. And that would be 22. And here's the thing, guys. I can't combine these two. You may say, oh, well, can't we combine those? Look at their radicals. This is radical 5. That's radical 3. That's like saying this. 5x plus 3y. Or excuse me, sorry. 5x plus 5y. You can't combine those. They're different variables. These are different radicals. Okay? Different variables, different radicals there, so I can't combine those. And I can't do anything else. So, guys, that's my final answer. All right, last problem of the day, guys. Last problem of the day. 5 plus radical 3 over radical 2 minus radical 3. So I'm going to multiply radical 2 plus radical 3 on the bottom. Complex conjugate. And I'm going to do the same thing to the top. Okay, so here we go. Let's go with this first one. First would be 5 radical 2. 5 times radical 2 is 5 radical 2. Outside would be plus 5 radical 3. Inside, radical 3 times radical 2 would be plus radical 6. And then radical 3 times radical 3 would be plus 3. So again, going through that FOIL. 5 times radical 2 is 5 radical 2. Outside, 5 times radical 3 is 5 radical 3. Inside, radical 3 times radical 2 is radical 6. And radical 3 times radical 3 is 3. I put that all over. And then I'm going to do my a squared minus b squared here. So that would be radical 2 squared minus radical 3 squared. That's just 2 minus 3. So that's negative 1. So I just need to change all my signs up here. So that would be negative 5 radical 2 minus 5 radical 3 minus radical 6 minus 3. When you divide by negative, you just change the signs. All right, any questions of me, guys? Any questions of me? If I don't see any questions, give me a thumbs up that you are good for 5.2 notes. All right, so I have Andy's good. Adam, I'll answer your question in a second. Kenzie's good. Andrew's good. Catherine's good. Jesse's good. Tara's good. Okay? Good. Very good. To answer your question, Adam, is the Zoom thing on Thursday mandatory? Absolutely not. You don't have to come to, I think you guys are Thursday at 5 o'clock. You do not have to come to that. That is not mandatory. Just if you want to like get together for a few short minutes, talk to each other. You can ask me questions. You can talk to me. Whatever you guys want to do. If no one shows up, I'll still be there. If one person shows up, I can talk to them or whatever. So just giving you an opportunity to see each other, to talk to me in a different setting than me just you seeing me without me seeing you. So there are no questions. You guys are good to be dismissed. I'll see you guys Wednesday. Make sure today, tomorrow, or Wednesday morning you get 5.2 homework done. We'll go over it in class and then we'll continue on. If you have any questions between now and then, you guys know to shoot me an email. You guys did, most everybody turned their homework in, so I appreciate that so much, guys. So, hey, thanks so much for your attention today. You're dismissed, guys. If you have any questions, just type them into the chat box. I'll stay here for a few minutes.